Good morning, everybody. My name is Asif Khan. I'm a technical business development manager with AWS, and we're going to talk about the wide range of AI services available on the AWS platform. So let's talk a little bit about the history of artificial intelligence at Amazon. Amazon started as the online book store, as you might know, and then into e-commerce and so on and so forth. Now, when you look at your screen right now, we have done AI for many years through our Amazon.com website. Today at Amazon, we have a wide range of services to offer you so that you can leverage the different parts of the AI services. At Amazon, thousands of employees across the company are focused on AI. Starting from discovery and search, fulfillment logistics, defining new product categories like Amazon Echo, and bringing machine learning to all through AWS. But in the recent years, the deep learning space has accelerated quite a bit, and that has happened mainly for three reasons. Newer and better algorithms have become available. Secondly, there's a lot of rich data which is now accessible publicly, and there have been improvements on the hardware side with GPUs and acceleration, which gives you that power needed for doing parallel computation, which in the past used to take quite a bit without the hardware power. And finally, there are new programming models which have come across in the last 5 years, which have really accelerated the deep learning space. And the way we look at this is AWS provides you all of that on a platform that is easy to use, and we'll show you throughout this presentation of the different options available to you as developers. So let's talk about Amazon AI. First of all, we are a founding member, or we support the Apache MXNet project, which is a deep learning framework. It has inherent benefits like imperative programming, massive parallelization, and so on and so forth. We also have managed services like Amazon Poly, which is text to speech, and Amazon Recognition, which is around computer vision. These are managed at a layer where you can call APIs and the system will return a response to you. With Apache MXNet, if you want to go more hands-on and develop your own algorithms and your use cases, you would go there. And finally, we have also Amazon Lex, which is basically the NLU and the ASR unit. Let's talk about MXNet in a little bit more details. So, as I said before, MXNet is programmable. It's very simple to start with. It supports multiple languages and it's very portable. So you could take a model, build it on a GPU machine, and then run it on a CPU machine. We also have examples on MXNet tutorials where you can run this on a Raspberry Pi, or any other IoT device. So MXNet models are very portable, and you can also right size them for the device you're going to deploy or the environment you're going to deploy them with leaner version. In fact, there's a JavaScript version for MXNet to run on your browser also. I would highly recommend you to visit mxnet.io for the tutorials and the examples. The part of MXNet which is really exciting for me is the high performance. It has near linear scaling across hundreds of GPUs. What does that mean? That means that I can run very performance intensive jobs in a very predictable fashion, and then run massive parallelization on data and build my neural networks to make sure that I'm predicting the correct way. MXNet is an open source software. It's like accepted into the Apache incubator, and it is the best to run on AWS. And we have also published a optimized deep learning AMI on AWS, and we are providing integrations with other AWS services. Having understood what MXNet's benefits and deep strengths are, Amazon MXNet is the deep learning framework of choice for Amazon, and we are building on top of this. We support you through multiple options. For example, we have the P2 instances or EC2 instances at the hardware level, and they give you up to 40 CUDA cores, and that's the amount, and you can use them for parallelization. We have the deep learning AMIs, the Amazon Machine Image, which is basically pre-configured for deep learning libraries like MXNet and other libraries that you can use out of the box without configuring the armies. And we also support or make available deep template or deep learning clusters that you can use to run your deep learning algorithms. Having understood or learned about deep learning framework, where if I want to go hands-on and build those models on my own or my algorithms on my own, then I would go to MXNet. But for enterprise applications or things like chatbox, maybe I want a quick way of implementing that, and that's where Amazon Polly comes in. Amazon Polly converts text to lifelike speech. It is fully managed, which means that you can build bots on top of Polly and go from there. It supports 47 voices, 24 languages, and it has a very low latency and it acts in real time. So let's take a listen how Amazon Polly sounds.
And of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversations?
With Polly, we have a very high degree of focus on voice quality and pronunciation. So we try to automatically and accurately text process and give you the sound back. So let's take a listen to the first sentence, which is today in Seattle, Washington, it's 11 degrees Fahrenheit.
Today in Seattle, Washington, it's 11 degrees Fahrenheit.
Let's take a listen to the next line, which is we live for music live from Madison Square Garden.
We live for the music live from the Madison Square Garden.
So these examples show you the quality of voice and the pronunciation it provides you based on text translation. It is intelligible and really easy to understand. So let's play that and see what that means.
How much would a woodchuck chuck if a woodchuck could chuck wood?
And also it adds semantic meaning to the text. For example, if there's a phone number, it'll try to identify and play with it. So let's play the two audio and see the output.
Richard's number is 2,122,341,237.
Fair enough. And
Richard's number is 212-234-1237.
So you saw the semantic meaning to the text, where the first recording was really about putting out a large number in terms of the way we speak naturally, and then the system also understood that this was a telephone number and then started talking as if it was reading out a phone number. And then you can have customized pronunciations. For example, you can say my daughter's name in Kaya in multiple pronunciations. So let's take a listen.
My daughter's name is Kaja. My daughter's name is Kaya.
And you can control these right from the manage interface, which we will see at the end of the webinar. So in a nutshell, Polly gives you this high quality, best in class, like deep learning text to voice kind of an environment. It is very deep in functionality with different types of voices, pronunciation, semantics, and the intelligence that is built into that. And it's integrated with the AWS platform. Customers are using this, it's built for production, and it's really cost optimized and directed towards keeping the cost low. Having seen Amazon Polly, which is text to speech, let's have a look at the computer vision problem of AI that AI tries to solve. And we have Amazon Recognition, which gives you that capability. With Amazon Recognition, you do real-time and batch image analysis. You can do object and scene detection, facial detection, and also facial analysis and face searches. So, for example, in this picture that you see, the deep learning algorithm behind recognition says that there's a 99.18% confidence that this is a bay, followed by similar outputs that this is a beach, coast, outdoors, and it gives you the different aspects of the object in the pictures. Like for example, it goes down to the level of saying there's a tree in this, there is a plant in this, or there's a palm tree in this, and you can use this for building complex applications on top of this. Let's take a look at facial recognition or facial detection. Amazon Recognition identifies emotions. In this example, the girl in the picture is calm and the confidence is 73%. She is not wearing a sunglass, her mouth is not open, her eyes are not closed, and she's not wearing any glasses. There's the mustache, she doesn't have a mustache and no beard. So it gives you a very fine level of facial analysis on top of an image that you submit to Amazon Recognition. So you could use uh, Amazon Recognition for things like facial verification on badges. You can compare two faces, like when I walk in and against an image that is already stored. You could do a face search, which is basically comparing many faces. And you could also do a visual similarity search where you can find similar faces. It is again very built with very high quality and through best-in-class deep learning implemented. It is fully integrated down to the AWS platform, and customers are using this in production today. And again, towards our goal is towards driving it towards a low-cost environment. Let's talk quickly about Amazon Lex. Amazon Lex is the natural language unit of the Amazon AI services. So let's first understand what it means. Firstly, the conversational interactions, the first generation was really machine-oriented analog interactions that you see or that we did. The second generation was really the web and the mobile web, where we could have conversational interactions on the devices and the web. And finally, the third generation is towards intent oriented, where basically your intent controls the conversation and it's not controlled by a machine oriented interaction or a control oriented interaction. Lex builds those natural conversational interactions in voice and text for you. Now you can do that through voice and text chatbots. It powers Amazon Alexa, or our home assistant service. It also enables voice interactions on mobile, web and devices. Amazon Lex has very deep integrations, text integrations with Slack and Messenger, and more to come on that. And we also have enterprise connectors to enterprise systems like Salesforce, Microsoft Dynamics, Marketo, and so on and so forth to provide you that voice and text capability to build conversational interactions around enterprise software also. So looking back, what we saw with Lex, as again, the intent is to give you the best-in-class deep learning with deep functionalities and at production grade and keeping the cost low. Having seen the different aspects of Amazon AI services, how do all of this stack up and what should I use when? At the lowest level, we have the AI infrastructure, which is Amazon EC2 and instances like the P2 instance and the G2 instances for computational power. We also have AWS Lambda, which is a serverless uh, environment, and you can run uh, MXNet or AI services on top of that. And then we also have AWS IoT and GreenGas to provide you the device-based capabilities. On top of this infrastructure, you can lay out AI frameworks. And if you want to kind of do it yourself environment, then you would be at this layer. So you would basically deploy a deep learning army, the AWS deep learning army, which comes with different kinds of libraries like Apache MXNet, TensorFlow, and you will develop your models on top of that and deploy. You could automate, or you can make it even easier to consume by using Amazon Machine Learning or EMR or Spark and Spark ML. Those are platforms that you can run on and build your models and algorithms. And finally, at the highest level of abstraction is AI services. These are managed services which are supposed to accelerate your development lifecycle and give you AI capabilities, like Amazon Recognition, which is image recognition and detection and analysis, Amazon Poly, which is text to speech, and Lex, which is voice and text chatbots. So depending on where on the stack you are and depending on how deep you want to go on the AI modeling and algorithm side of the house, you can use the different layers of Amazon AI services or infrastructure that is provided. How do I get started with Amazon AI? You can get started by going down to the aws.amazon.com/amazon-AI link, and you a very easy, a good way to start is the Amazon Machine Image for Deep Learning, and download that and spawn up a EC2 instance, and now you get all the libraries you want. You can install a Jupyter notebook, and you can actually do your analysis and things like that. We also have AWS CloudFormation. Building a cluster of these instances is always hard. So the CloudFormation template gives you an easy way to scale up to multiple instances, like for jobs such as training deep neural networks, and you don't have to worry about setting things up, scaling them out, trying to tie them together with different ways and making them communicate. This comes out of the box for you. As you can see, I'm on the Lex console, and you can navigate to the Lex console from the Amazon web console, and you can see Lex and recognition, and I've navigated down to Amazon Lex, and here you see an example of a bot, which is basically like there are a couple of samples you can try, which is book trip, order flowers, or schedule appointment. So with the book trip, you are booking a hotel. The intent is to book a hotel at a particular goal that the user wants to achieve. You can put in utterances, which is spoken words or type phrases that invoke your intent. Like for example, here I would say, I would like to book a hotel. This translates back or triggers a conversational interaction which asks you which city. And then you can have slots where the data could be provided to fulfill the intent by the user. In this case, the user says New York City. And finally, the conversational interaction, you can define prompts that you can ask the user for input data, like what date do you want to check in, and then finally use the business logic to fulfill the user intent. In this case, you might want go to a booking site and book it and come back and say it's booked and the email is on its way. So that's how easy it is to build a Lex bot. You can always build a custom bot with your own and define more, but I would start with a sample, try it out, and then go from there. The second demo which or piece which is really interesting to see and touch and feel is the Amazon recognition. So in this example, you're seeing object and scene detection. There's a skateboarder who is skateboarding on a street, and Amazon recognition recognizes with a 99.2% capability the different aspects on this picture, which is skateboard, it's about sport, there's a person there, there's a human that's parking on this, and so on and so forth. And you can find very deep image analysis with Amazon recognition out of the box. You can also have a look at image moderation. So there's no moderation label detected on this. So if I see this is basically going back there. Now, similarly, this is a female's swimwear or underwear kind of a scenario. And then for facial analysis, like we talked about, it detects the various ranges of the picture of the face and predicts that emotion of, in this case, smiling. We just released something called celebrity recognition, and in this case, Amazon recognition recognizes that this picture is of Jeff Bezos. And as we talked about, you could do face comparison and you could see where the Amazon recognition can give you a similarity of 92% for two pictures which are similar to each other, and it could be used in many use cases where facial recognition becomes important.